All righty. Hello, everyone, and thanks for joining my session on Terraform at the Network Edge. My name is Robert Belson, and I lead our developer relations efforts here at Verizon. And today I want to talk a little bit more about a use case for Terraform that you may have never thought of, particularly as you think about the evolution of 5G mobile networks. You probably never thought about ways that Terraform can be used to automate cloud infrastructure within these 5G networks and use cases in turn that these type of architectures will unlock. And so over the course of the session today, I want to talk a little bit about what Verizon 5G Edge is, how we use Terraform, and then specifically how network intelligence can be used with Terraform to solve challenges around identifying the most optimal edge endpoints in a world where you have an ever increasing distinct volume of edge infrastructure locations to choose from. And so let's start by asking a fairly simple question. And as we rather unpack the 5G and 5G edge and ask ourselves, well, where is the edge? Because after all, the edge could be a device, could be the radio networks that you see, or rather the towers you may see as you're driving along a highway or looking outside your window at home. But to us, as we think about the edge, we're really focused on the mobile edge, particularly as that first point of entry for all of these different devices within our network. Think about it the following way. In a 5G network, you have all of these different radios that if I'm consuming a mobile application, phone connects to a radio, all of these radios converge to an access point or aggregation point. And that's precisely where the packet core sits. And it does all sorts of different functionality, including being that gateway or exit point to the internet at large. So wouldn't it be nice to actually put cloud compute within that very location so that traffic doesn't have to go out to the internet and then eventually find its way to that cloud endpoint? Wouldn't it be nice to just have that compute co-located within the mobile network itself? And that's exactly what the mobile edge means to us. Because even if you had a data center or CDN or any type of compute endpoint within your very backyard, from a mobile network topology perspective, our mobile edge will always be topologically closest. So one way you can think about this is precisely that point where mobile traffic anchors to an IP address and can then in turn connect to the rest of the internet. That's exactly what the mobile edge means to us. And think about Verizon 5G Edge as an overarching portfolio of mobile edge computing solutions, of which AWS Wavelength is one of them. And so what is AWS Wavelength? At the end of the day, it's really just another availability zone, but it happens to correspond to the Verizon carrier network and a number of different locations within it. And so much like AZ's, it's a logical extension of a region. So it's not itself a region. It's really just an extension of the region. And it inherits properties like subnetting and route tables as availability zones themselves. So that's a really key point. And what you see here on the right-hand side is a quick little map of 17 different locations where you can deploy. So in the case of the US today, GovCloud aside, you have your 4 regions in AWS, but now you have 17 different locations in addition that you can deploy everywhere from Boston and New York City to Seattle and Miami, Dallas and Denver, the list goes on. Isn't it awesome now that take Miami, Florida, for an example? Today, if you were delivering an ultra immersive application, that traffic would probably have to travel from Miami all the way back to Northern Virginia. And having done that drive recently, let me tell you, that's a pretty long drive. And similarly, from a mobile traffic perspective, that's also a long distance. So wouldn't it be nice to cut out all of that latency associated with the transport from Miami all the way through the internet to Northern Virginia, US East 1, and in turn, have that same compute or EC2 instance you know and love within the mobile network itself, within the Miami region, or rather Miami general geography? That's incredibly powerful. And as you think about exposing those resources, that's where carrier IP addresses come in, because they're not technically public IP addresses because they're only accessible within the Verizon mobile network. However, they behave very similarly to public IP addresses. And so carrier IP addresses essentially can be both launched ephemerally on launch, as you would through the EC2 console, or statically via elastic IP addresses. But they're just Verizon carrier network reachable IP addresses. You'll see I have a little screenshot here. It's an extension of the same concept within the console. But under the covers, what's really happening is that it's a Verizon pool of addresses exposed through the AWS console to seamlessly manage both public IP addresses and these carrier addresses corresponding to all of these different geographies from a single pane of glass. And that's incredibly powerful. Now, let's set up the problem statement here. Why Terraform? Why are we here today? The reason we're here today, in my mind, is that, well, at face value, some of these architectures or key architectural concepts and wavelength zones and carrier IPs are fairly simple. The reality is that these architectures get complicated fairly quickly. Give you one example. As you think about EKS or Kubernetes, the control plane still lives in the region. So EKS, while it's available in AWS wavelength, the control plane does not live in wavelength zones. That's not supported. You actually keep the control plane in the parent region, and you have all of the edge zones, one to many, or however many you'd like, running node groups, unmanaged node groups. So self-managed worker nodes, you can basically run the EKS AMI. Point is, that's one layer of complexity, just getting complex infrastructure patterns spun up. 2, you're managing multiple locations at once. 3, there's all sorts of carrier networking associated as you think about the carrier gateway, which we'll get into, unique carrier route tables. But one other area that I think is very important to call out that we'll talk more about later is it's not just about step 1 in deploying your infrastructure. It's also about deploying your network infrastructure, things like the edge discovery service, because in an EKS world with 5, 6, 7, 8 node groups, all within a single cluster, if each of those 8 regions are geographically distinct, you want to make sure your traffic is routed to the most optimal or lowest latency edge. That's a fairly non-trivial task to implement yourself. I mean, things you could try to do is ping every single one of those edge locations and then reverse engineer the latency. You don't want to do that. You'd want to rely on something like geolocation-based routing within DNS. But if you were to try to pop in any of these carrier IP addresses within a geolookup tool, it's going to say you're in Kansas City or something. It's not helpful because the network topology, the mobile network topology itself, is not accessible by DNS at large. So you need a different solution. That's what the Edge Discovery Service provides. But all in, complexity from network infrastructure, complexity from new architectures themselves, new carrier networking appliances or software abstractions within AWS. You don't want to manage this yourself, and you certainly don't want to do this manually. So what if there was a better way? Alas, we believe one such way is through Terraform, because simply put, it makes my life easier. Obviously, you can use Terraform to automate AWS wavelength resources, as long as the AWS provider supports it, which we'll show you it does. But what you may not have known is that some of these challenges around edge discovery and network intelligence can also be automated through Terraform. And we'll show you one example that we think is pretty nifty. I think the best place to start now is just to start to walk through some of these Terraform fundamentals, get familiar with some of the new concepts that are being introduced. And then let's go into a live demo and see what happens. So wavelength zone subnets. So what is a wavelength zone? If you look at the console, you won't find it because while it is a new service, it's inheriting existing services. So the way that both the console abstracts wavelength and the Terraform provider extends it is that when you want to launch a wavelength zone in one of these 17 geographies, it's just another subnet. And the way you launch a subnet, of course, is you have a VPC, an existing one. So in this case, I have TF-VPC. You have a CIDR range associated with that subnet. And then there's an availability zone attribute that today you might put in something like US East 1A. All you would do in this case is add in US East 1, WL1 wavelength, BOS, Boston, WLZ wavelength zones. That's the nomenclature that AWS wavelength uses. Tag accordingly, and you're off to the races. It's truly that simple to get a wavelength zone up and running. There's no crazy allow listing needed in your console. All you have to do is opt in within the zone section of VPC, or you can do the same in the zones area or section of account attributes within EC2. Point is, it's about 30 seconds to opt in to these edge zones, and you're off to the races here. Now, carrier gateway. What's that? We briefly mentioned it, but just to sort of circle back here, carrier gateways, similar to internet gateways, take care of network address translation between the private IP addresses scoped within your VPC itself. And then that traffic to these carrier-facing IP addresses or carrier IP addresses. And you'll notice within Terraform that it was exposed as just another resource, or AWS underscore EC2 underscore carrier underscore gateway. So it's just a carrier gateway resource. All you do is you specify a VPC ID, and that resource is created and attached to your VPC. Worth noting that even if you, again, 8 wavelength zones all within a VPC, the reality is that it's still one carrier gateway, even though technically there's natting happening in 8 different physical locations. It's just one software abstraction per VPC. I think that's an incredibly powerful point. The beauty of 5G Edge is that we've abstracted away the network complexities so that you can focus on building your applications. And I think this is one great example. Going back to the route tables here, it's just another route table. You would just add a unique route, perhaps for all of your traffic. Let's say it's like a web server. So you would want to have a public subnet in this carrier scoped wavelength zone. So you would have a route table saying, okay, local traffic goes through the local router. And then, of course, you have a default route. So 0.0.0.0/0. You want to go through the carrier gateway. So this should feel familiar to what you would expect with an internet gateway. So here you would just specify a new attribute that was introduced by the AWS route resource as carrier gateway ID and pop in the logical resource ID of that carrier gateway as you see here. One last key concept that I want to introduce. So again, we've talked about wavelength zones, we talked about carrier gateways. How does carrier IP works? It's actually very simple. Within Terraform itself, the only way to do that today is through elastic IPs. So you can't assign through the EC2 instance or AWS EC2 instance resource. There's no field right now that says allocate a carrier IP auto-magically. The way you have to do it through Terraform, with exception to a unique property on launch templates. Let's just focus on perhaps the easiest way here, and that is through EIPs or elastic IPs. So that screenshot earlier that we showcased of the console of basically picking a network border group and then clicking allocate on that first slide. The other way you can do that, of course, is through Terraform. So you just say, okay, in this VPC, I would like to allocate an address corresponding to this really wavelength zone, which they call here network border group, but you'll notice that string is exactly the same. And then when you've created that elastic IP, you attach it to a VM. That's the fastest way to do it in Terraform. And there you have it. 1, 2, 3 steps to building that first application at the edge. Before we go into a demo, I do want to just highlight a few things about the Edge Discovery Service, just really walking you through what's happening, and then we'll jump into a demo encompassing everything. But as we think about Edge Discovery, so imagine a world where we have 3 wavelength zones or 2 wavelength zones, still one carrier gateway, remember, because one VPC, one carrier gateway, but 3 different carrier IPs. Perhaps you have subnets in Boston, New York City, and DC. And then the carrier IPs that were allocated were these 3 addresses you see here. So 155, 146, 225, and then .19, and then .12. So if you're a mobile device, which is the closest edge? The answer is, as a mobile device, you have no idea. You need to ask something else. So we've created here at Verizon what we call our Edge Discovery Service. Think of this as a simple service registry that keeps track of all of the different carrier IPs associated to an application. And then the second you want the closest endpoint to you, you just query this service registry saying, hey, I'm a mobile device. Here is my IP address. Now you tell me the closest edge. And it makes the decision on your behalf because it's more complicated than just what is closest to me geographically. That's not relevant. It's about the mobile topology. Where am I in the context of the mobile network and all of the changes surrounding the network itself? That's how decisions are made. And that's what the Edge Discovery Service does. So with that in mind, how does this all come together? Let's just highlight a quick demo of what you do. So let's start with a quick setup. What you would do is you authenticate to the API itself. You would create a service profile, characteristics associated with the profile itself, populate in all of your IP addresses. And then from the mobile device perspective, you'd say, hey, I want to authenticate with the API. And then you tell me the closest edge. So in this case, what's happening is you would authenticate to EDS, you create the service profile. You're seeing that exactly here. And then that service registry, that alphanumeric string, you then pass to the client side, and it would tell you in turn the closest IP address. So that's a quick primer on how the Edge Discovery Service works. But the point today is really to start thinking about that building of really a 5G Edge future with Terraform and how we use automation. So in the demo today, we're going to showcase two different capabilities, day one and day two. I'll actually work backwards here. Starting with day two, we want to have some sort of capability or module that can automate the network configuration so that no matter what happens to my wavelength infrastructure, all of my carrier IPs are up to date. And then I want to think about just how do I provision infrastructure on wavelength? And that's exactly what we're going to talk about today. And I've created a little module here that we'll walk through. I think it's time for a quick demo. So that's what we're going to go ahead and go do. So I'm going to start with this EC2 module, and I'm going to boot it up and then talk through what it is that we're actually doing. What essentially it does, and we'll inspect, is it's a series of event bridge rules that are always hunting for changes in my account. And anytime there's a change to an EC2 instance, so a lifecycle event happens for an EC2 instance, a Lambda function is triggered to say, okay, were any of these instances carrier instances? And if so, it's going to find all of the EC2 instances with a carrier IP and then populate them into the Edge Discovery Service. But then you might say, well, wait, that's too broad. You might have different conflicting applications with different carrier IP addresses. So we said, you're right, that would be potentially dangerous. We should have a way to filter by a given tag. So what do we do to inspect this module a little bit further? Of course, we have our keys that are stored in like a secret.tfvars file. We have a region that this is scoped to, but it's also looking for a specific application tag. So it's an optional variable here. It defaults to wavelength-app. So if you have a tag in your application whose value is wavelength-app, this module will ingest it and then take that information and populate it to the Edge Discovery Service. So at the end of the day, what this module is, if we just quickly inspect, let's actually go to the application itself. We're going to go here and go to specifically our Lambda function. The easiest way to find it is actually going to the Terraform registry itself and looking at the GitHub. But the point is, really all it is a Lambda function inspecting all of this information and populating the Edge Discovery Service. So 200 some lines of code from the initial module, now 5. And so as we talk about automating and simplifying operations, that's exactly what we've done here. So now that we have that booted up, let's go over to Wavelength. This is the fun stuff. What are we launching? So we start with the VPC. This is all familiar. Then we have here our region subnet. So again, if you wanted to have a bastion host, we're setting that up for you. 2 subnets in Wavelength. And again, if you want to look at here, we have variables corresponding to each of the 2 wavelength zones that you want to launch in. So this time I'm doing US West 2. So I'm using the San Francisco and Denver wavelength zones in the US West 2 region. I have a security group for the bastion host, security group for my edge wavelength hosts, an internet gateway and a carrier gateway respectively. Again, we talked about the carrier gateway here. And then as we create a route table, you'll notice here this wavelength zone route with that carrier gateway ID attribute. And then you associate that to the wavelength zone subnets. Really that simple. And then when you launch an AWS instance here, you'll notice that you just specify that wavelength subnet. Really that simple. Again, you'll notice this is very, very, very similar to the AWS operations you know and love. Of course, that one distinction here being when you create that carrier IP address, you allocate an elastic IP, you specify the wavelength zone, and off you go. Truly that simple. Now, let's go ahead and launch this, then we can talk a little bit more about what it is that we're doing. Let's go ahead and launch this. So what's happening? Remember, the network intelligence has been automated. We have this Lambda function being triggered by lifecycle rules anytime an instance is created with tags that are matching wavelength-app populated into this Edge Discovery Service. We're able to do all of that automation with 5 lines of Terraform using this module capability that we find so valuable. But now we want something to actually be triggered. So best way to do that, let's launch 2 instances, one in the San Francisco wavelength zone, one of them in the Denver wavelength zone. You'll see here, edge instance 2 running. Let's just double check here in instances. You should see some of these resources coming online here. All righty. So you'll see we have an edge instance here that's slowly starting to launch. And you'll see that it already has an elastic IP, 155, 146, 2211, 155, 146, 144, 33. So as this becomes running, I guess even before we do that, let's inspect this. You'll notice, again, the wavelength abstraction is such that even though this instance is actually within the Verizon 4G and 5G network within San Francisco, it just shows up as yet another availability zone. And its public IPv4 DNS is created from the underlying carrier IP address that was allocated. So you're just building on what you know and love. And then worth mentioning that if you inspect the networking tab and you go to the subnet in which it was deployed, you'll notice that the route table will look awfully familiar to what you would expect. Go to the route table here, scroll down. You have your local route, and then you have your default route through the carrier gateway. So of course, if this was an internet gateway, it would say something like IGW hyphen giant string. Idea here being that this is very familiar. It's really, again, inheriting those properties you know and love. And using Terraform, we don't have to touch the console. It just makes everything so much simpler. So again, if we go back as this starts to create, what's actually happening? Well, the desired behavior of this, including the outputs of this module, is within AWS Systems Manager, there's a parameter store feature. And in parameter store, it will give me the ID of the service endpoint, so the service registry, so that I can use it in subsequent invocations. So if we go here under application management, click parameter store, you'll see a bunch of different parameters that were created. So for an example, you'll see that there is an application name here. So this is that tag again that it's hunting for. And in the initial module, you can add a variable or input field to say, hey, actually don't look for wavelength app, look for my hyphen app. And the module will constantly hunt for that set of tags instead. Now, let's go back to parameter store. In particular, we're looking for this one, the service endpoints ID parameter store, because that's the service registry ID that we're going to use to actually see what edge is closest to me. Worth mentioning here that I'm in the Northeast area. And so if I go into this little client side here, and I pop in under service endpoints ID, the new service endpoints ID. Save this, go run it. You'll see that's the closest edge to me. So what I'm doing here is I'm using an IP address in the San Francisco area to simulate as if I was in the West Coast right now. And of course it says, surely enough, aha, the closest edge zone to you is San Francisco. So that was a great way to test this locally. But the point is, this is how you can use Terraform to do some really, really interesting things, not only to automate the compute infrastructure, but all of the networking surrounding it. So that's the overall demo I wanted to showcase today. And it's all enabled by really that modular structure afforded by Terraform to do things that once would require cobbling together hundreds and hundreds of lines of code. It saves so much time by being able to use this edge discovery module I built out. So not having to keep all of these Lambda functions up to date and change management, just having this module structure has helped me and helped our developers save a bunch of time and remain agile as we ultimately explore this greenfield opportunity in the mobile edge. And so we've already talked about our sort of demo here, but in sum, we're super excited to go along this journey with you. And we'd love to get your feedback. Feel free to test out this module, try AWS Wavelength, let us know what you think. And if you want to learn more about the Edge Discovery Service, I invite you to check out our reInvent presentation that we did. You can also go to our Verizon 5G Edge blog on Medium, check us out on Twitter, go to verizon.com/5G-Edge. And thanks so much for joining us this afternoon. And I'll turn it back over to the HashiCorp team. Thanks so much.